Okay, we're going to continue with decision analysis using the Horowitz criteria. This criteria is based on assigning a level of optimism. Level of optimism that the user would state based on the optimism of having a good state of nature. So this level of optimism is basically alpha. We use that symbol to represent the level of optimism, so that with two states of nature, if, for example, the level of optimism that we believe will warrant good economic conditions is 0.4. Basically, this level of optimism is going to range from 1 to 4, or from 0 to 1. And the bad economic condition, the other state of nature, is going to be 1 minus alpha, or 0.6. Now, the level of optimism is based on our idea of our own level of risk, you could say, of how optimistic we are that a good economic condition will persist. So in this process, I'm going to label our decisions 1, 2, and 3. Make it a little easier, because what we have to do is we create a different or another table. There's our 3 decisions and our states of nature. Now what we do is we multiply alpha for the good economic condition by each of the payoffs for the decisions. So 50,000 times 0.4 is going to give us 20,000. 0.4 times 100,000 gives us 60,000. 60, where did I get 60 from? Sorry. 0.4 times 100,000, if you do the math correct, is 40,000. I should have a blooper reel. And 0.4 times 30,000 is 12,000. Now for the second state of nature, the bad economic conditions, we're going to multiply the payoffs by 1 minus alpha, or in this case 0.6. So 0.6 times 30,000 gives us 18,000. 0.6 times negative 40,000 gives us negative 24,000. And 0.6 times 10,000 gives us 6,000. What we do to continue this on is basically we add these values together. So this is going to be equal to 38,000. This one is going to be equal to 16,000. And the last one is going to be equal to 18,000. And we're going to choose the best of those options. So in this case, we're going to choose, we're going to invest in the apartment building. That's our choice based on this criteria, based on Horowitz level of optimism criteria. Now, one thing that I like analyzing is this value here, 0.4 and 0.6. What happens if our optimism is actually higher or actually lower? How does that change our decision? At what point would our decision change? So it's like a sensitivity analysis based on the level of alpha. Now what I'm going to do, I'm going to show you an Excel file that you can create. We need this just for one part of this decision analysis, sensitivity analysis, I should say. It's the same example. Let's make this a little bigger so we can see it in the back row. Where we have our payoffs, we have the coefficient of optimism, alpha value 0.6, and then 0.4, and then 0.6, and the payoffs, and our decision. These are the values we just calculated. So what happens if one thing we need to determine is, are we always going to be choosing apartment building on any level of optimism? So let's make the level of optimism really small, say 0.1. And I built this in, so everything is going to change. If it's 0.1, we're going to choose the best payoff is apartment building. How about if it's really high? Well, now the best choice is an office building. So it's going to change between apartment building and office building. And if we go in the middle, we can see that it's apartment building. We will never choose the warehouse. Let's put that back to 0.4. So in this analysis, there's going to be two options, either apartment building or office building. Let's go back in here. Let's get to an empty slide here. Let's discuss and determine how we actually determine what the sensitivity analysis for that level of alpha, for that coefficient of optimism. So basically, we want to calculate alpha to determine that point at which we are indifferent. Between the two choices, between the choices. So we know that we are either going to choose the apartment building or office building. When the coefficient of optimism was 0.4, we chose office building. When it was actually higher, we would choose the office building. So what we're going to do is we're going to take, let me bring back the diagram here, our chart. Let's find it here out of my mess of, there it is. We need this back. And there it is. What we're going to do is, we know that ultimately we're either going to choose apartment building or office building. Under this process, the warehouse is not chosen as a final decision. So what we're going to do, to make the numbers easier, we're going to work in tens of thousands. So we're going to then put alpha as the state of nature, for the good state of nature, and 1 minus alpha. And we're going to solve for alpha. So we know that eventually at some point alpha changes, the level of optimism changes. It's going to change our decision from office building, apartment building to office building. So at what point is it going to change? So if we take the office building, 50,000 times alpha, plus 30,000, this value here, times 1 minus alpha, similar to what we did when we calculated, when we used 0.4 for that level of optimism. We'd go 50,000 times 0.4, and then 30,000 times 0.6. We're now just using these variables in there. What we want to determine is there's going to be a point for alpha at which the decisions, the payoff for apartment building is going to be the same as the payoff for the office building. So the office building is going to be 100 alpha minus, because of the negative sign, 40 times 1 minus alpha. Basically, the equality states that this is the apartment building here. Those are the apartment numbers. There's going to be a point where our decision, where we are indifferent between choosing or investing in an apartment building versus investing in an office building. Knowing this will help us understand how confident we can be in our level of optimism. So if we calculate this out, we get 50 alpha plus 30 minus 30 alpha. Over here we're going to get 100 alpha minus 40 and then plus 40 alpha at the end. So solving this through, 50 alpha minus 30 alpha is 20 alpha plus 30. And that's going to equal 140 alpha minus 40. Getting alpha values on one side and the other values on the other side, we're going to end up with 120 alpha, and then adding 40 to both sides, we get 70. So basically at this point, let's write it over here, alpha is going to be 70 divided by 120. That equals approximately 0.583. That tells us that if the level of optimism is 0.583 or less, we're going to choose an apartment building. If it's 0.583 or more, we're going to choose that office building. Let's use our Excel sheet to see if this actually works out. So we know that if it's 40%, which is less than that 0.583 value, we choose office building. If it's more, say 0.8, we choose the office building. So if we enter exactly that value, 70 over 120, 58% approximately, 42% for 1 minus alpha, look at those values, they are identical. So it basically tells us that if our level of optimism is more than 58%, like 0.8, we're going to choose the office building. If it's less than that 58%, like what it was originally, 0.4, we're going to choose the apartment building. So this tells us that point of indifference between those two ultimate choices. It also gives us a great deal of, increases our confidence in making this decision. If we are thinking like, well, I'm only 30% confident, that comes with some range as well. So if we're only 30% confident, we're going to choose the apartment building, knowing that even if our level of confidence or our level of optimism is wrong, it has to be wrong by quite a big deal for us to actually choose the other choice.